So this video is on integrated 2MA notes on piecewise functions. Okay, so piecewise functions are where we have different parts of graphs put together to form a graph. So on this first one here, I have a line y equal x plus 5, and I have a parabola x squared, y equal x squared plus 2x plus 3. I don't want the whole entire line, and I don't want the whole entire parabola. For the line, I only want it where x is less than or equal to -2. So I only want from -2 back. For x is greater than or equal to -2, I only want it from -2 on for the parabola. Now I'm going to put it into Desmos just to show us what it looks like. So I grab my Desmos. Okay, I put the equations in. This is what the line looks like. This is what the parabola looks like. This is what the line and the parabola look like, but I don't want all of the line because I want to go where it is -2. Okay. And here I just want from here down. For my parabola, I want from -2 on. Okay, that's what I want. So on Desmos, you can give some restrictions. So to restrict my x, I'm going to do the squiggly bracket set notation. X is less than -2. And I get that. So you can see that this got shrunk. It's going from -2 down. And this one, I want x is greater than or equal to -2. And this is what our graph looks like. Here is this linear piece, and here's this parabola. And again, from -2 on down, I have this line. From -2 to the right, I have this parabola. That's what we're going to do. Okay. So I'm going to start with my line. And what I'm going to do for my line is I want it only starting, not including, but I'm going to use that as a boundary point, -2. So I'm going to put -2 in here. -2 plus 5 is 3. So I'm going to have a point at -2 comma 3. So I'm going to go to -2 comma 3. And let me just, so I'm going to go to -2 comma 1, 2, 3. I'm going to put my point. Okay, maybe I'll make it a little thicker. Now I put this point here. Honestly, I don't want it to be a solid dot. I want it to be a open circle because it's not including. It's not including because there's no equal. There's no equal on that. Okay, so I only want from -2 down. So I'm going to go to -2, 1, 2, 3. I'm going to have an open circle. And I don't want to go this direction. I want to go this direction because I want x's smaller than -2. So my slope here is a 1, but instead of going up 1, over 1, up 1, over 1, which is out of the interval they want, I'm going to go backwards. So I'm going to go down 1, left 1, down 1, left 1, until I get off this graph. I'm going to connect this with a line. And that is the first portion of this. The next portion is where my x's are greater than or equal to -2. So I'm including the -2. What I personally do with my parabolas is I first find my vertex and go from there because I don't want to have to make a table. So I'd rather not be plugging in values if I don't have to. But this is not in the nice graphing form. So I'm going to use the formula -b over 2a, which is going to give me the x coordinate of my vertex. So I'm going to have -2 over 2 times 1, which is going to give me a -1. I'm going to plug -1 into the equation to see what I get. So I get 1 minus 2 plus 3. I get a -1 plus 3. I get a 2. So my vertex is going to be -1 comma 2. So I'm going to go to -1 comma 2. That's my vertex. Now, They want me, let me just draw this in real quick. They want me to basically have a different graph on either side of that x equal -2. So I still need to do a little bit of the parabola to the left, but then I'm going to be focusing more on the right. So since this parabola is just plain old x squared, I'm going to go out 1. 1 squared is 1. I'm going to go up 1. Out 2. 2 squared is 4. I'm going to go out 1, 2, 3, 4. That's all I'm going to be able to fit on this graph. Now, if I go the other direction, left 1, 1 squared is 1. What's going to happen is that open circle is now going to be filled in with the blue graph. And then I connect, and there's my graph. On the next one, I have another line and parabola. Okay, so this time I want to go, my x's to be greater than or equal to 1. So I'm just going to draw this line in temporarily. Okay, so x is greater than or equal to 1. This is where my x's are 1. So I'm going to be looking at that kind of as my divide here. Okay, so for the first one, for my line, my first value is going to be 1. So I'm going to put a 1 in here. 2 times 1 plus 1. So I put in a 1, and it looks like I'm going to get out a 3. So I'm going to go to 1, 3. 1, 2, 3. This is going to be a solid dot, okay, because it does have that equal underneath it. Okay. And then I want to go to the right because I want x is greater than or equal to 1. And my slope is a 2. So I'm going to be going up 2 to the right 1, up 2 to the right 1, and so forth. And this is my line. The second part of this is going to go to the left of that. And let me find the vertex. The vertex for this is going to be 0, 3. So I'm going to go up to 0, 3. And when I go out 1, 1 squared is 1. So I'm going to go up 1 because, again, this is just a plain x squared. And this is going to be an open circle. Okay, so you can see that they didn't fall on top of each other like they did in the last graph. And on the pink line, the that endpoint is solid. It's included. But on the blue parabola, it's not. It's going to be open. Okay, so I went 1 squared is 1. I'm going to do the same on the other side. 1 squared is 1. I'm going to go out 2. 2 squared is 1, 2, 3, 4. I'm going to graph my parabola. Just get rid of that line. And that's what our graph is going to look like. In this case, they did not touch at all. And this here on this graph, 1 is not included. I don't have a point here. Here, 1 is included. Okay. On the next page, this one I've got 3 different graphs. I have a parabola, I have a line, and then I have a horizontal line. Okay, that's the ones I have. So for the first one, I want my x's greater than or equal to 0. Okay, so really I'm going to have 3 different sections of this where my x is 0, my x is 1, 2, 3, 4, 5. You don't need to draw this in. I just want you to understand. These are the 3 sections of graph. I'm going to have graph over here. That's going to be a parabola. I'm going to have graph over here, which is going to be an increasing diagonal line. And then I'm going to have graph over here, which is going to be a horizontal line. Okay. So for the first one, for the parabola, let me write my vertex. My vertex is going to be 0, -1. Okay, so I know my 0. Okay, so I'm going to go 0, -1. Okay, and it is solid. It is included because of that equal. I am going to be going to the left of this. So when I go out 1, 1 squared is 1. When I go out 2, 2 squared is 1, 2, 3, 4. When I go out 1, 2, 3, 3 squared is 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And I have my parabola to here. Okay, my next piece is a line. Okay, and I'm going to go from 0, not including 0, to 5. So let's find our 0. Our 0 is actually going to be our y-intercept. Okay, and so when I put in 0, I get -1. It's going to be my y-intercept. So I'm going to go to 0, -1, which is going to be an open circle, but it's already filled in by the blue graph. Okay. And then my slope is 2. So from here, I'm going to go up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1, not forever, up 2 over 1 until I get to here, because that is where my x is 5. I only want to go from 0 to 5, from 0 to 5. This is a solid dot because of the equal. This one would have been an open circle, but it's already included in the parabola. And then I connect, and that's that portion. Now, the next piece of this is a horizontal line, and I want it from where x is greater than 5. So I'm going to go to 5. I'm going to go up 1, 2, 3, because this is a horizontal line at 3. And that is my graph. On the next one, I have 2 parabolas. Now, these 2 parabolas are, and hold on, I can come and take this from here. Okay, I don't need those. Over here, I want on either side of 0, in this case, I'm gonna have 2 separate pieces of graph. So this one is going to be for my basic parabola, which has a vertex at 0, 0, and the 0 is included. So I'm going to have here 0, 0. I'm going to be going to the left. Okay. So 1 squared is 1, 2 squared is 1, 2, 3, 4. 3 squared is 5, 6, 7, 8, 9. And there's my parabola. Now, the other part is going to be greater than 0. The vertex for this is going to be 0, 4. So I'm going to go to 0, 4, 1, 2, 3, 4. Now, this is an open circle. Okay, the other one below was a closed circle. Now, this is a parabola that opens down, and it is still just an x squared, but it's negative. So I'm going to go over 1. 1 squared is 1, so I go down 1. Over 2, 2 squared is 4, so I'm going to go down 1, 2, 3, 4. Over 3, 3 squared is 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. And so forth. And there's that. Now, again, I don't need that line there. That was just kind of showing where my divide is. Okay. Now, on these 2, okay, this time we're going the other way. They're giving us the graphs, and we're going to be writing out what the equations would be. So for this, let me just kind of show that this is kind of where we have the split. And that is where my x is -2. Okay. So I've got this graph here. And then I have this graph here. So if I'm looking at that purple graph, okay, that is going to be a line. When I write this, I'm going to go f of x is equal to, I'm going to do a big set notation. I'm going to put my 2 equations there. So for this purple one, this is my start, and that is at -2, 1, 2, 3, and it is open. Okay, I know it's hard to tell because I put colors there, but it was open. So that is at -2, 3. And I'm really having a slope of 1. Now, how I can write a line that is, maybe I don't know the y-intercept for, I could figure it out, but maybe I don't want to. We can write it y equal your slope m. You can also think of it as a, like we do for a parabola. X minus h plus k, where h comma k is equal to a point on the line, and m is your slope. Okay, this is in kind of point slope form. Normally, your top point slope form y minus y1 equal m times x minus x1. That's what we think of as point slope form. The only thing I've done over here is we have the x minus x1 and we added the y1. And this is where x1, y1 equals point on line. Okay, but I want to think about it this way, because that's kind of the form we do our parabola, the form we do our absolute value. It's going to be the form we do all of our graphs. That's how I'm going to write mine. So I'm going to be using that -2, 3. Okay, so what I'm going to do is I'm going to have my slope. I'm going to write the one. I don't really need it, but I want you to see that that's where my slope would go, times x. And because of this -2, what makes that a -2? And x plus 2 would have given me a -2 plus 3. That is my line. And it's fine to leave it like that. Again, you don't need to put the 1. We can take the 1 away and just have it like this. Now that does clean up to x plus 3, but I want us to understand that you don't have to necessarily find the y-intercept and put it in y equal mx plus b form. Now, I don't have the whole entire line. Remember, we are having this divide between at -2. And this was open, so this is going to be x is less than -2. Now, the red one is really a horizontal line at y equal -2. So I'm going to write -2 because that's f of x equal -2. And its x is greater than or equal to -2. Okay, now on the next one, we've got 3 pieces here. Okay, I'm just going to get rid of that. So the 3 pieces, I have this at 3 and at 6. That's going to be my intervals. So before 3, between 3 and 6, after 6. Okay, so this point right here is at 3, 3. So that point is at 3, 3. And if I look at my slope, I'm going up 1 every 3. So it's going to be a 1/3. So I'm going to write 1/3 times x minus 3 plus 3. And that was a solid dot. So I can either include it, I'll just include it here. I need to include it in either the red or the blue, that 3. So it's going to be x is less than or equal to 3. Now, the parabola. I need to find the vertex. The vertex of this parabola is going to be 4, 2. And you'll notice I'm going over 1, 1 squared is 1, over 2, 2 squared is 4. So it's a regular parabola just centered at 4, 2. So this is going to be x minus 4 squared plus 2. I'm going from 3 to 6. Now, I'm not going to include it at 3. I've already included it in 3 above. To 6, and let's include it on 6. Now, the next part is this green part here. So the last one here is this green line, and its starting point is here at, let's see, 6, 6, it looks like. And the slope for this is a -1. So I'm going to write the -1, but I don't need to. I just put a negative if I want. Times the quantity, x minus 6 plus 6. And I've already included the 6 in the parabola, so I'm just going to say x is greater than 6. Hopefully this helps you out, especially those who are absent today.